There's nothing else. No one can ask you to do anything else here. So when we differentiate the left-hand side and differentiate the right-hand side, we know that the right-hand side is f of x, and the left-hand side is 12x cubed.
Wouldn't the right-hand side be f of t?
No, because we have to put x in here. It's a function of x. It's not a function of t. The integral is from 2 to x. So that's why the result is a function of x.
So that's the answer.
That's it.
Is 3x to the fourth minus 48 the antiderivative of f of x then?
Say it again.
Is 3x to the fourth minus 48, that's the antiderivative of f of x then?
Yes,
Oh, okay. Gotcha.
correct. So that was one. Everything else was, I was hoping that on 4b you will realize that this function is undefined at 2, so
That took me so long.
good.
I stared at it for way too long.
I was hoping that you would notice that the integral from 10 to 10 must be 0 no matter what function, so you didn't. So 4a, the integral from 10 to 10, there is no discussion there, right? The answer is 0.
I took that time to figure it out.
Good,
I just-
That's
you know, I
good.
just wanted to be thorough.
I
good,
didn't know how to write it,
excellent.
so I just wrote it out too.
I want to applaud few of you who on 4e noticed that the function is even, and they calculated twice the integral from 0 to 3. Thank you so much for that. And that's pretty much it.
Or f odd function.
I'm sorry?
Except for f odd.
Yes, odd function because of tangent. Yes, very good. The results are very good. Yes, which one? Yeah, when you see C,
Yeah.
so that's the integral from arc tangent x to the 5th over 1 plus x squared dx. So obviously what you
So
have,
it's du on the problem.
all right, yeah, of course it's dx. Oh, yeah, I'm so sorry. Oh, I had a typo in there. We cannot have, in an integral with, in a single integral, not a double or triple, we can only have one variable. Yeah, sorry about that. My mistake. Okay, anything else? Before we look at the squeezing theorem.
Number one.
Yes?
I didn't get the sign correct. It's
So we want to look at number 1?
yeah.
Okay, very good. So we have f of x, which is e to 2x plus 4 divided by e to x. And we have u of 0. Oh, this was u. I'm sorry. U prime of x.
Yeah.
Okay. And u of 0 is 2.
Yeah.
Okay.
Now you can split those into two
Yes.
things, and then that cancels out e of x on the bottom on the left side.
Yes. So once you separate it, yes. So u prime of x will be e to 2x over e to x plus 4 over e to x. So this is e to x plus 4e to negative x.
Yeah.
So now, which function prime is e to x? Well, the answer is e to x. But which function prime is positive e to negative x? And that must be negative e to negative x plus a constant c.
Okay.
Now let's check, because we can check at all times when we look at an indefinite integral. This prime is that? Yes. This prime, of course, the 4 in front. This prime is that? Yes. Because when I differentiate e to negative x, I have e to negative x times the inner function prime times negative 1 will give us the plus. So then we have that u of 0 is 2, which means 2 equals 1 minus 4 plus c. This is negative 3. Move to the other side, which is 5. Always check, right? Always check, because you cannot do that with a definite integral. So.
Okay.
So then the function is, the unique function that has that derivative is u of x e to the x minus 4e to negative x plus 5.
We go over 7 also.
Yes, of course. So let me write e to the x.
Yeah.
E to the x minus 4 e to negative x plus 5.
Can you do over 2 after number 7?
So into f is 0. The function is odd, and the interval is symmetric. That's all you had to write.
Wait, for which one?
Are you talking about 4f?
No, number 2.
Oh. Oh, yeah. I'm sorry. Which number we were looking at? 7. Yes. Okay, so let's take a look at 7. And then we go back to the Riemann sum. So we have the integral from 0 to 1 from x squared sine x dx less than or equal to 1. Okay, so we start with, of course, x. That's what we know. And now, if you remember, when I apply, so let's look at the graph of sine. So this is pi over 2, which is a number greater than 1, and here is 1. So the graph of sine is this, right? It gets to 1 here at pi over 2, and then it starts dropping. So the function is increasing. So sine 0 less than or equal to sine x less than or equal to sine 1 radian. So I'm applying sine to all 3 sides because sine is increasing. I keep the inequality symbol as is, or the inequality symbols as they are. Okay, so now, since I don't have the left-hand side, I'm going to drop this side. It doesn't matter. So I only know that sine x is less than or equal to sine 1 for x between 0 and 1, of course. So therefore, I am allowed to multiply both sides by x squared. So then I have x squared sine x less than or equal to x squared times sine 1. And then I integrate from 0 to 1. There's nothing I can do here. I can simplify that, and I have x to the third over 3. And this is a constant that goes in front. Sine 1, no one wants to touch. It's a number. From 0 to 1. I only plug in 1, and I get 1/3 times sine 1 radian. And this is guaranteed to be less than 1 or equal to 1. So if you plug it in, you will see what number you get. Definitely less than 1 because it's not pi over 2. It's just sine 1 radian. It's not pi over 2. So it's definitely less than 1. Multiply by a number less than 1. The product will be less than 1 for sure. You don't even have to calculate this. Because this maximum can be 1, which is not the case. It's going to be less than 1. But less than 1 times 1/3 will definitely be less than or equal to 1. Okay, we want to go back to number 2 for now, and then squeezing theorem or something else if you have anything else from this test. So we have f of x, 2x cubed plus 4x plus 8. There is no secret. You will have a problem like this on the final exam. Here's why. Because half of Calc 2 is the summation notation. Integration by parts and other techniques of integration, and then series. And you're going to see the summation notation, the steam will come out of your ears like this. So that's why this is so important. Okay, so we had the interval 0, 4. And we want to determine the integral. So we determine the integral if you, can you please tell me what was the x, what was 190 something?
194.
Very good. Okay, perfect. So I would do that first. Okay. So now I have 3 preps. The first prep is delta x, 4 minus 0 over n. Then xi. Thank God it starts at 0, right? So I have 4i over n. And then f of xi will be 2, 4i over n to the third plus 4 times 4i over n plus 8. You did not cube everything. you only cubed I, or you only cubed n, you did not cube 4. So of course that's okay. It happens. It happens. It happens, right? Is that clear?
Yep.
So you have to be very careful. Take it easy because this is so important. Once you have this simplified, then you can put it in the limit of the Riemann sum. So this is 2 multiplied by 4 to the third is 64 I to the third over n to the third plus 16I over n plus 8. That's why we don't put it in before we completely simplify it, because it's so much. So even when you look at it, you see the limit, you see the summation notation, you see the I, you see delta x, you see f of x. You want this to be fully simplified before you put it together, because otherwise you make your life miserable. So then I have 128 I cubed over n cubed plus 16I over n and plus 8. Now I will say the area is the limit as n approaches infinity. And in order to cut back a little bit, I can already put 4 over n in front, cut back on writing a little bit. And then the sum of this, I can put 128 in front, n cubed, the sum of I cubed, plus 16 over n, the sum of I, plus 8, the sum of 1. So now if you have difficulties with this, I would write everything. So now we have to replace these 3 pieces. This gets replaced by n squared plus 2n plus 1 over 4. This piece gets replaced by n plus 1 over 2, and this piece gets replaced by n. So being able to manipulate and work with the summation notation is extremely important for moving forward. Okay, and you'll see what happens in the next class. Okay, so now I write limit as n approaches infinity 4 over n, 128 over n cubed times n squared plus 2n plus 1 over 4 plus 16 over n times n plus 1 over 2 plus 8n. Now try to see if you can come up with a least common denominator without having to multiply the tops, because that makes it more difficult. So if I will definitely simplify the n squared with n cubed. So now, can I simplify the 2? Yes. Can I simplify the 4? Yes. And I will do that. So then I get 32 here, and I get 8 here. It's nicer because the denominator is only n, right? So once you do that, limit as n approaches infinity 4 over n, and the least common denominator is n. So now 32 gets distributed here. So 32 n squared plus 64n and plus 32. Now I will not simplify because I really want the n in there. So plus 8n squared plus 8n. But this one needs an n. So this is 8n squared. Now I collect the terms. At this point, I'm happy if you stop, more or less, because I will have to collect 8 plus 8, 16 plus 32, which is 64. And the numerator goes to 4 times 64. The denominator goes to 1. But if you want one more step, let's write one more step. Limit n approaches infinity, n squared. So 64n squared plus 72n and plus 32. Say it again. Oh, yes, just n. I'm sorry. Yes, of course. Oh, no, it's n times n. Yeah.
No, sorry. Yeah.
That's okay. So now the numerator is 4 times 64, and the denominator is 1. So this better. So what did we get? We get 192 here, or 196?
192.
It was 192?
Yeah. I mean, even if it was 196, it's still too high. That's what 2 more.
So that's
So 8 plus
Oh,
8. Oh, yeah, okay. I'm sorry. 8 plus 8 is 16.
Right.
Uh, 48. Sorry. Okay, so 48. It better be 192. Sorry about that. Very good. Yes. So 64, and then you can use L'Hopital's rule if you don't remember, but since it's the same degree over same degree and the limit is and approaches infinity, it's the leading coefficient over the leading coefficient. Very good. Next, is there anything else from this? Okay, can we go to the squeeze theorem then? Say it again, Paul? No, Reed was asking to start reviewing. So do you think we still have, we should still review anything from from the last test? Or should we go back and focus on test 1, 2, and 3?
We'll have the solutions.
I already posted them. Yes, for test 4? Yes. Yes, and tonight I'm going to post the rest, meaning the bonus for test 3, the quiz 4, and quiz 5. Because I wrote solutions before I graded them. And please don't forget, Paul, if you want to, I'm not forcing you, but if you'd like to fill out that student opinion forms, I'll add 5 more points. But they will be closed on Sunday. So if you can do this between now and Sunday, let me know. Okay, so we want to look at the squeeze theorem, so let's go back to squeeze theorem in chapter 2. I think you learned a lot this semester. Would you agree?
Yeah.
Okay. Okay, so I'm trying to choose from the end of chapter.
Was it chapter 3?
This is chapter 2, actually, the squeeze theorem. And here it is. Yes, way back. So limit as x approaches 0 from x squared cosine 1 over x squared. So this is 0, and this is undefined. It's not even infinity or 0 or anything like that. So I can't really use an indeterminate case here. Okay, so then I will say, fine, let's look at cosine. And I know that cosine x is a number between -1 and 1. And so will cosine 1 over x squared. Cosine of anything must be a number between -1 and 1. So now, since I need this function in the middle, I will, like before, I will multiply all 3 sides by x squared. And I have to make sure that x squared is not 0 and it's always a positive number. So when I do that, I get -x squared less than or equal to x squared cosine 1 over x squared less than or equal to x squared. So the first hypothesis is fulfilled, meaning that this is a function f and this is a function g, and our function is squeezed between those two. So that's part 1 of the squeeze theorem. So I'm going to say the first hypothesis. I'm going to call this function h of x. H of x is squeezed between f and g near 0. I don't care what happens afterwards. Number 2, limit of -x squared when x approaches 0 and limit of x squared when x approaches 0 both exist and they are equal to
0.
yes. Therefore, by the squeeze theorem, from 1 and 2, what do I conclude about the limit of x squared cosine 1 over x squared as x approaches 0?
0.
It must be 0. Because we showed the first part, which means the function is squeezed between those two near 0. I don't care, outside of near 0. And since both limits exist and they are the same, because they may exist but they're not the same, and then I can conclude the squeeze theorem does not apply. And then I'll say the limit of h of x must be 0 as well. Good. Next question.
Precise definition.
Of the limit. Very good. Awesome. Oh, awesome. So let's find the limit as x approaches 2 from 2/3 x plus 1. What is the answer? Excellent. So this is equivalent to saying that for every epsilon greater than 0, I will find a delta greater than 0 such that whenever I pick a number close enough to 2, whenever I pick a number close enough to 2, how close? Not bigger than delta, away from 2. This will always imply what? 2/3 x plus 1, this is the function, minus 7/3, the function minus the limit, the function value for that x will be epsilon away from the limit. Do I need to refresh your memory on this? Okay, very good. So at the bottom I have 2, right? That limits the function, and then I have 7/3. Here I have 7/3, and here I have 2, right? For every epsilon around 7/3, I will find an interval around 2. Delta, the width of the interval is delta, right? So that when I pick an x here, f of x will be very close to 7/3. How close? Less than epsilon.
Yeah, so the -2 comes from the limit, right?
-2 comes from the limit, yes, because I have to pick x close to 2. Not 2, but close to 2. Delta close to 2. Not here, but within the delta. So once I pick an x within delta, f of x will be within epsilon away from 7/3.
And if it was -2, then it would be x plus 2.
Yes, correct. Yes. Okay, very good. So we start here. So we have 2/3 x minus 4/3 in absolute value less than epsilon. But this is the same with 2x minus 4 over 3 in absolute value less than epsilon. And you will know what I'm going to do next. I will never do that because I can't take care of the absolute value. Remember, my target is this. And if I separate, I will never get it.
So you can split.
I will never split. I will factor out 2. That's good then. Oh, that's good. So then the absolute value of 2, the absolute value of x minus 2, the absolute value of 3 less than epsilon. Excellent. So then I have 2, the absolute value of x minus 2 over 3 less than epsilon. So therefore, the absolute value of x minus 2 will be definitely less than.
3 epsilon.
Excellent. So then delta must be.
3 epsilon.
That's it. And yes, I have to write just one minor sentence. I have to show that 3 epsilon over 2 works by reversing the steps from before. So step 2, show that delta equals 3 epsilon over 2 works by reversing the steps. Any questions here on this so far?
So the thing at the end says reversing the steps.
Yes, I have to write that.
Okay.
Good. Next type of problem. Anything else? I would highly recommend redo all your tests, all 4, between now and Saturday, at least twice, maybe 3 times. And come back on Saturday and say, I still need a problem like this or a problem like that. If you do, I will make a list. Once you redo all your tests, you may say, I think that this problem I need more work with or something.
Our final is our lowest test score. Is that the test that you try?
No. If your final is the lowest test grade, that will be your final letter grade. No, I'm kidding. I'm kidding. Good. Next question.
Let's go with intermediate value theorem.
Yes.
Let's just keep moving up the ladder.
Very good. The intermediate value theorem. Good. So let's say find a solution to sine x equals x. I shouldn't say that because then we should use Newton's method. Let's put them together. Find a solution to this.
Let's do that.
Yeah, we're going to do it together. Yes, yes.
That's sine x.
Sine x equals x. No one can solve this by hand. There's absolutely no way. A computer can.
This is for the intermediate value theorem.
For intermediate value theorem and also for Newton's method. Because I'm not saying show that there is a solution, I'm saying find it. First, you have to show that there is a solution. You have to find the interval where the solution is using the intermediate value theorem because the function is continuous. And then you have to use Newton's method to find it. Okay, so in step 1, I write sine x minus x equals 0 and denote f of x by sine x minus x. In step 2, I have to write that f is continuous on, I don't know, I'll have to check. And I have to find f of those endpoints. So I have to put the function in. So let's put the function in. Oops. I did not have this ready, sorry. So let's put in sine x minus x and try to find an interval, a 1 unit length. It can be smaller, but not bigger. You cannot say it's between -5 and 10. So sine x,
0, 1.
is it 0, 1? Okay, second and table. I have to go back and change this all the time. Okay, you said 0, 1. Good enough. Oh, but the solution is 0. So okay, let me go back and if it's the only solution and there is no other, I have to change the equation. Sorry about that. Okay, so I'm going to put +1. Sorry. So it's +1. Because then there is no point in finding or using Newton's method, right? We want something that we cannot solve by hand.
Wouldn't that be x minus 1?
Yes.
Oh, that's just a big minus.
No,
Oh.
it's an error. It's a big error. Sorry about that. Okay, so now what is it?
Between 1 and 2.
Okay, so we go back to y equals. Okay, -1. So then second and table. And so 0 and 1. Okay, so I see it. It's somewhere. I hope it's not -2. It cannot be -2 anyway. So -3 and -2 So that's, okay, -4.
Yeah, -1, negative.
Okay, so between -1 and -2?
Yep.
Good enough. So the interval is -2, -1. And at -2, we got 0.0907. At -1, I got -0.8415. Very good. That's all I needed. So then I will say from 2 by the intermediate value theorem, there exists a C in the interval -2, -1 such that f of C is 0. So this is quoting the theorem. So if the function is continuous and it changes sign on an interval, it must cross the x-axis there. It must have a solution there. So we know there is a solution between -2 and -1. So in step 3, I will be using Newton's method. I will find f prime of x first, which is cosine x minus 1. I will create the function g of x, which is x minus f of x over f prime of x. So sine x minus 1 over cosine x minus 1. And I don't know how many decimal digits we want. Let's say 4. Is 4 enough? 4. Good. So let's go back and put the function in y equals. I want to insert x minus in parentheses. That's the top. Close the parenthesis and divide in parentheses by cosine x minus 1 and close the parenthesis. Oh, I didn't mean that. I meant this. Okay, so mode, yes, radians. Good. Y variables, call function 1, y1, and I want to pick either -2 or -1. Which one?
-2.
-2 it is. Press enter, and then I copy, overwrite previous answer, close the parenthesis, delete everything else, and I get this, and I repeat, and I get this, and I repeat, and I get this. So it converged after the first iteration. So it's -1. I don't need these two because I already have 4 digits. I actually have 6 digits already. So it's -1.934563. 8.
And 0 is the first one, right?
The first one is when we plug in -2.
Right?
Correct.
Okay, so it's -2 or is it the result? It's a result, right?
Yes, so this is basically x2 directly. -1.934563, and x1 was -1.935951. So that's one of the applications, right, of the intermediate value theorem to help us find an interval where Newton's method will help us find the solution. The intermediate value theorem, as I mentioned a long time ago, it only tells us where the solution is, but it cannot determine the solution. Newton's method determines the solution with as many decimal digits as you want, or as much accuracy as you want. Very good question.